Hello. This presentation on PFAS is part of a series of technical webinars provided by Comprehensive Environmental Incorporated, also known as CEI. My name is Emily DeFranco. I'm a senior scientist at CEI. CEI is a civil engineering and environmental consulting firm that works with local, state, and federal agencies, educational institutions, private industries, and other corporations. Please visit CEI's website at www.ceiengineers.com for a list of other webinar topics. This presentation will provide an overview of PFAS, including sources and a timeline of production, a discussion of environmental and health impacts, progress of state and federal regulations in addressing these emerging contaminants, and available treatment technologies for PFAS. Per- and polyfluoroalkyl substances, also known as PFAS, are a family of thousands of man-made fluorinated organic chemicals produced since the 1930s. Unique properties of PFAS make products that are oil and water repellent, temperature resistant, and reduce friction. PFAS are known as an emerging contaminant because they are still being studied. The major sources of PFAS to the environment include the manufacturing industry through air and water pollution, fluorine-containing firefighting foams, waste from industrial discharges, and direct human contact through specific commercial products including nonstick cookware, outdoor textiles and sporting equipment, and many others. PFAS compounds are man-made and have a long history, beginning in the 1930s with the development of PTFE, a PFAS compound used to make Teflon. Throughout the 20th century, additional PFAS compounds were developed to produce nonstick coatings on cookware, water-resistant products such as waterproof rain jackets, firefighting foam, architectural resins, and others. By the beginning of the 21st century, the United States began reducing the production of some PFAS compounds as potential health and environmental impacts were identified. Following this reduction, EPA released a health advisory regarding PFAS, and individual states began developing their own standards and advisories. As noted, the production and manufacturing of specific products has been shown to release PFAS into the environment either through air pollution, directly through products, or through waste disposal. Once in the environment, the carbon-fluorine bond that characterizes PFAS is so strong that it does not break down naturally and travels through surface and groundwater. Humans ingest PFAS through multiple pathways, including drinking contaminated water, eating food transported in PFAS-laden packaging, or through direct product use. Once in the body, PFAS has been shown to cause certain types of cancers as well as other human health problems. There are currently no federal regulations for PFAS chemicals. In 2016, EPA released a health advisory for two PFAS compounds, PFOA and PFAS, of 70 parts per trillion combined, and has begun to develop a regulatory MCL for these compounds. EPA released its National PFAS Action Plan in January 2019 with an update in February 2020, and is currently going through the process of determining future regulations specific to PFOA and PFAS under the Safe Drinking Water Act and the Clean Water Act. Federal cleanup programs, such as CERCLA, recommend a screening level of PFOA and PFAS of 40 parts per trillion to determine if a site may warrant further attention. Individual states are developing their own standards and guidelines to address PFAS compounds in their drinking water. States must consider the following questions when developing these standards. How prevalent are PFAS in the environment of the state? How detectable are they? What are the costs and benefits of establishing a standard? And what is the appropriate standard that is protective of the most sensitive populations? States in New England are currently working to develop their own regulations for PFAS compounds. Massachusetts and Vermont have proposed standards of 20 parts per trillion for 5 or 6 compounds. New Hampshire has stricter regulations that became effective in 2019. The regulations are currently on hold due to a lawsuit filed by the company 3M and several others alleging New Hampshire DES failed to consider the costs and benefits of these strict standards. This lawsuit is ongoing. Maine and Connecticut currently use EPA's health advisory recommendation of 70 parts per trillion for PFOA and PFAS, but have recognized the need to develop a standard and are currently working towards that goal. There are treatment technologies available to remove PFAS. The unique properties of PFAS compounds make this challenging as the carbon-fluorine bond is difficult to break. Often, longer chain molecules are simply broken down to smaller chain molecules instead of removing PFAS from water. New methods have been developed to address PFAS in water. Non-destructive methods that rely on adsorption and filtration for removal, and destructive methods used to break apart PFAS compounds. Both methods have been shown to be effective in reducing PFAS in water. However, destructive methods are the only method available to break the strong carbon-fluorine bond and remove PFAS from the water column completely. Though non-destructive methods are effective at removal, treatment includes the production of PFAS-laden filter material that must then be disposed of. The three primary non-destructive treatment technologies for PFAS include granular activated carbon, ion exchange resins, and reverse osmosis. All methods have been shown to remove over 90% of PFAS from the water column. However, this type of treatment does not destroy PFAS compounds, resulting in either a solid or liquid waste stream containing concentrated PFAS, which must then be managed. Destructive treatment technologies to address PFAS are able to break the carbon-fluorine bond, effectively removing PFAS from the water column and breaking it down into harmless compounds. This mineralization occurs through incineration at over 1,000 degrees Celsius and often requires a significant energy demand. Electrochemical, thermal, and ultrasonic methods have been developed to remove PFAS at heavily contaminated sites. CEI has experience managing PFAS and other contaminants at hazardous waste sites and for drinking water treatment. It is our experience that one size does not fit all when it comes to treatment. Treatment should be based on the concentration of PFAS at your site, your removal goals, available resources, and other site-specific factors. We have experience working with clients to identify the best combination of methods to treat PFAS and other contaminants. Thank you for watching this webinar. For more information on PFAS management or for information on drinking water treatment or hazardous waste site remediation, please contact Emily DeFranco, Mike Ohl, or Rick Cody, or visit CEI's website.